You know that bag of fertilizer you see in fields all over the world? Well, it's pretty much the cornerstone of modern agriculture. It's a key ingredient in feeding our entire planet. But what if what's inside that bag isn't what it claims to be? Today, we're going to uncover the truth about nitrogen fertilizer, from some simple tests you can do in the field all the way to some sophisticated lab analysis.
And that is the critical question for every single farmer. The answer can literally be the difference between a massive successful harvest and complete financial ruin. See, as the demand for crops skyrockets, so does this hidden threat that can poison fields and bankrupt the people who work them.
And believe me, this isn't some small, isolated problem. As this quote from Kitty Cuddy points out, it's a huge, growing threat. Farmers are being sold stuff that's useless at best and downright harmful at worst. So, what can you do? Well, the very first step in fighting back is knowledge, understanding what it is you're actually buying.
To make an informed choice, you really have to know what you're working with. Nitrogen isn't a one-size-fits-all kind of deal. It actually comes in different chemical forms, and each one has its own unique properties and its own way of impacting your crops.
Okay, so this slide really highlights a crucial trade-off. You've got nitrate, which gives plants an immediate boost of nutrients, but it can get washed away by rain really easily. Then there's ammonium, which acts more like a slow-release fertilizer because it clings to soil particles. And finally, you have urea, which needs to go through a whole conversion process in the soil before plants can even use it. The right choice really depends on your specific needs, your soil type, what you're growing, and even the weather forecast.
Now, let's put two of the most popular options head-to-head, urea and ammonium nitrate. As you can see, urea is that slow-release fertilizer we just talked about, while ammonium nitrate gives you the best of both worlds. It offers immediate and long-term benefits. But the real game changer here is the nitrogen content, and in that department, urea is the undisputed champ.
And this number right here? 46%. This is exactly why urea is so incredibly popular. At 46% nitrogen, it's the most concentrated solid nitrogen fertilizer you can get. What that means is you get more nitrogen in every single bag, which translates to lower costs for transportation and for application. It's really just a matter of efficiency.
Okay, so knowing the types is step one, but how do you actually spot a fake? Well, luckily you don't need a lab coat and a microscope. Turns out your own eyes are your most powerful tool. So here's what you need to look for. Genuine urea is going to be white, shiny, and kind of translucent, with these perfect, uniform, round grains. Now, if your fertilizer looks dull or clumpy or uneven, you should be suspicious. It could be mixed with anything from sand to salt.
And hey, if you're still not sure after looking at it, there are two really straightforward tests you can do yourself. They're quick, they're easy, and they could save you a whole lot of trouble down the line.
First up is the water test. It's as easy as it sounds. Just add some of the fertilizer to a container of water. Pure urea will dissolve completely. If you see anything left behind, any residue, your fertilizer is impure. The results are pretty much undeniable.
Next, you can try the heat test. Just place a little bit of the fertilizer on a hot pan. And just like sugar, pure urea will melt completely, leaving absolutely no trace behind. If you're left with any kind of gunk or residue, well, you've got a fake on your hands.
Now, while these field tests are super useful, the only way to get a truly precise measurement of the nitrogen content is to go to the lab. Here, scientists can figure out the exact composition of the fertilizer, leaving absolutely no room for doubt.
And the gold standard for this analysis is something called the Kildall method. It was developed way back in 1883, and it's been the most trusted method for measuring nitrogen for over a century. It's the same technique that regulatory agencies all over the world use to ensure quality and safety.
So how does it all work? Well, the whole process can be broken down into three main stages: digestion, distillation, and titration. I know it might sound complicated, but the goal is actually really simple: to isolate and measure all the nitrogen in that sample.
The first step is digestion. You can kind of think of it as a chemical pressure cooker. The fertilizer gets heated up with concentrated sulfuric acid, which breaks down the sample and transforms all the nitrogen into a single, stable compound called ammonium sulfate.
Next up is distillation. A strong base gets added to the sample, and that releases the nitrogen as ammonia gas. This gas is then captured in a special solution, which effectively isolates all the nitrogen from the original fertilizer. Pretty clever, right? And finally, we get to titration. This is the big measurement step. Okay, imagine you have a glass of lemonade, and you want to know just how sour it is. You could add sugar, 1 spoonful at a time, until it's perfectly sweet. Titration is kinda like that. A standard acid is added to the ammonia solution until it's neutralized. By measuring how much acid was used, chemists can calculate the exact amount of nitrogen in the fertilizer.
So, after all that rigorous testing, what do the results actually tell us? Well, this kilojule method gives us the hard data we need to make a really informed decision.
And here are the results. Just as we expected, urea has the highest nitrogen content at a whopping 46%. Ammonium nitrate comes in second at around 34%, and ammonium sulfate at 21%. It's also worth pointing out that ammonium sulfate also provides sulfur, which is another essential nutrient for a lot of crops. This data really empowers farmers to choose the absolute best fertilizer for what they need.
So, what are the key takeaways from all this? First, just be observant. A simple visual check can tell you a whole lot about the quality of your fertilizer. And please don't forget those at-home tests. They're so simple, they're effective, and they can save you from a very costly mistake. And second, you've got to understand the science. The kilojule method gives you the data you need to make an informed choice. But remember, it's not just about the numbers on the bag. The right form of nitrogen can be just as critical as the percentage. Choosing wisely really can be the difference between a crop that thrives and a harvest that fails.
Ultimately, making sure our fertilizer is high quality is about so much more than just protecting farmers. It's about protecting and safeguarding our entire global food supply. By combining that boots-on-the-ground vigilance with rigorous scientific analysis, we can build a much more secure and sustainable future for agriculture.